Welcome to Great Academy. In today's class, we shall be treating balancing of chemical equations. If today is your first time, please hit subscribe, then like, comment, and share the video. Now, most of the time, students complain about equations and balancing. So this tutorial class will explain everything from A to Z. It will as well give you tricks on how to get it easier with balancing of chemical equations. The first element, assuming it's a cation, will always attract the second element in the second compound. Now, the second element will always attract the first element in the second compound. So in this case, you are going to have AD plus BC. Okay, let's represent this using real chemical elements. So if you have HCl plus NaOH, this is hydrochloric acid reacting with sodium hydroxide. HCl is an acid and NaOH is a base. So the idea I gave to you in the first illustration, divide it into two. Sodium here will react with chlorine to form NaCl, and hydrogen here will react with hydroxide ions to form H2O. And I'm very, very sure that before now, you've known that hydrogen reacting with hydroxide will give you water. So in this whole equation, you can simply call it a neutralization reaction. A reaction between an acid and a base to form salt and water only. So this is acid, this is a base, this is salt, and this is water. Is that okay? Now, after reacting, the next thing to do is to balance. And as students might be passing and get to know how to balance, to react very well, but balancing will be a very big hurdle, and that is where you are being differentiated from other students' ability of you to balance very well. Now, in balancing, we have how many atoms, of the element that make up this compound? How many of them are present? So we have hydrogen, we have chlorine, we have sodium, and we have oxygen. So total of 4 elements make up these compounds. So you have to balance element by element. In the first compound, which is hydrochloric acid, you have 1 atom of hydrogen. And in the second compound, there is 1 atom of hydrogen here. In the second compound, you have same 1 atom of hydrogen. That is at the right hand side. You have total of 2 atoms of hydrogen. Now, what it means to balance is whatsoever you have at the right hand side must be equal to what you will have at the product side. So if you look at the right side, you find out that our H has a 2 that is 2 as a subscript, meaning 2 atoms of hydrogen. So we've balanced hydrogen. Now when you look at chlorine, you see that we have only but 1 atom of chlorine here, and here we also have 1 atom of chlorine. Now when you watch your sodium is Na. Sodium Na. Sodium is 1 atom here, and here sodium is what? 1 atom. Now remaining oxygen, which is still 1 atom of oxygen and 1 atom of oxygen, meaning that this equation is balanced. You don't need to add any numerical values or any value of any kind for you to balance it again because it's already balanced. Now let me recap on this. I told you that when you have two compounds, in those compounds there are elements that make up the compound, and those elements can either be metals or non-metals in this kind of equation right now. So you have hydrochloric acid, in which the hydrogen atom there is serving or acting as a proton. Then chlorine as anion. Then you have sodium as well, which is also a metal, and oxygen non-metal. So you divide the compound into two, differentiating the cation from the anions. Is that okay? Now the first cation in the first compound we combine with the second element, which could be a non-metal or a radical. Now the second element from the first compound we combine with the first element from the second compound. And whatever you have will become your product. And after balancing, you will not beat your chest that you are a good chemistry student. Now let's continue. If you have other reactions like this, H2SO4 reacting with Ca bracket OH2. This is hydrogen tetraoxosulfate 6 is an acid, and calcium hydroxide is a base. Alright. Now if you watch this, like what I said before now, divide it into two, SO4, which is a radical, sulfate ions, we combine with calcium to form a salt, CaSO4. And whenever that comes in contact with each other, they will form water, H2O. So one thing is very important today to note, that NaCl is a salt, a normal salt. Is that okay? Then the chemical formula of water is H2O. And the chemical formula of hydrochloric acid is HCl. The chemical formula of sodium hydroxide is NaOH. The chemical formula of hydrogen tetraoxosulfate 6 is H2SO4. And the chemical formula of calcium hydroxide is Ca bracket OH2. And the chemical formula of calcium tetraoxosulfate 6 is CaSO4. Is that okay? Alright. Now I divided them into two like I told you from the beginning. So we have hydrogen, combining with hydroxide to form H2O. And we have SO4 combining with calcium to form calcium tetraoxosulfate 6. Now the next thing left is the balancing. And like I told you before now, as a chemistry student, if you're able to react very well without balancing, it's as good as you cooking soup without adding salt. So let's balance. In balancing, you balance element by element or atom by atom. In these whole formulas, the principal element that make up these compounds are hydrogen, sulfur, oxygen, and calcium. And at different levels, some have subscript and some don't have subscript. So we have to balance it very well. And this is where it gets more interesting, because balancing is as easy as ABC. So if you look at the reactant side, which where we have the acid and the calcium hydroxide, which is a base, you'll find out that the first hydrogen here has two atoms. That is two atoms of hydrogen. Now in the second compound, we have OH inside the bracket, but outside the bracket we have two. And it's very much important to understand that the value outside the bracket will always govern everything inside the bracket. Let me repeat. The value, which is these two outside the bracket, will govern everything inside the bracket. So here you will have 2 atoms of oxygen and 2 atoms of hydrogen. So if that is true, if you have 2 atoms of hydrogen here and 2 atoms of hydrogen here, it means you produce total of 4 atoms of hydrogen. And you must give hydrogen at the product side 4 atoms, else you fail the balancing. And to do that, you come and add 2 here. These 2 will now multiply this hydrogen subscript, this particular 2 here, to produce total of 4 hydrogen atoms. So in this case, you balanced hydrogen. You now move to the next element, which is sulfur. So both sides, you have only 1 atom of sulfur and 1 atom of sulfur. So that does not need any balancing. Understood? The next thing left here is oxygen. And in the first compound, which is the acid, you have 4 atoms of oxygen here. And the second one, just what we explained before, 2 times 1 here will give you 2. So you have 2 atoms of oxygen and 4 atoms of oxygen. It means you must have 6 atoms of oxygen at the product side. Now let's check. You have these 4 here, atoms of oxygen, and 2 times 1 here, that will give you 2 atoms of oxygen. And 4 plus 2 will give you 6. Understood? Alright. If you've reached this point, congratulations, because balancing of chemical equation will soon be at the tip of your finger. You will never get to miss it again. Let's continue. The next element here is calcium. And both sides, we have 1 calcium atom and 1 calcium atom. It means everything is balanced. Is that okay? If you add the numbers, 2 plus 2, plus 1, 2 plus 1, alright, let me use the blue color, 2 plus 1 plus 4 plus 4 plus 1, that is 2 plus 1 plus 4 plus 1, yeah, then you have plus 2 and plus 2. So everything will be what? 2 plus 1 is 3 plus 4 is 7. 7 plus 1 is 8. And 8 plus 2 is 10. 10 plus 2 is 12. Meaning we have total of 12, at the right hand side. So let's check that of the product side. We have to get the same thing. So you have 1 plus 1 plus 4 plus 4 plus 2. So 1 plus 1 is 2, and 2 plus 4 is 6. 6 plus 4 is 10, and 10 plus 2 is 12. So we've balanced this chemical equation. We have equal number of atoms, at the both sides. And that is very interesting. And I know at this point, you are beginning to appreciate Sir Great Academy, because everything here is completely, for beginners, even for the advanced student. Because everything you'll be doing in chemistry, as far as inorganic chemistry is concerned, will always fall back to balancing. And once you get the balancing once you get it wrongly, then you risk failing the whole question. Is that okay? So we are going to be balancing as many equations as possible. Now let's look at another equation. Please, if you're still finding difficult at this point, I will advise you to go and rewatch. But trust me, if you're following very attentively and taking note of these things we are doing, I don't think you will have any difficulty. So let's continue. Let's try another thing. Let's say we have Um, let's try decomposition reaction. Let's have PB brackets NO3. Then you have 2. Let's see what this will give us. So this is lead trioxonitrate 5. Yes, I said lead trioxonitrate 5. I don't know who amongst you is finding difficult to name, but if you are one of those who are finding difficult to name, just the way I just said lead trioxonitrate 5, then subscribe so that my next video where I will explain naming of chemical compounds from A to Z will actually get to your inbox, and for you not to miss it. So subscribe and as well do like and comment. So if you decompose lead trioxonitrate 5, what you are going to have is lead oxide, PbO. This is chemical formula of lead oxide. Understood? Plus nitrogen oxide. Understand? Plus oxygen. So these are the products that will be formed. Some text will give you NO2 plus O. Well, I love PbO plus NO plus O2 because this is actually what it's supposed to be. Again, if you've gotten to this point, congratulations. So let's continue. You have lead, you have nitrogen, and you have oxygen as the principal element that make up this compound. And in this whole equation is called, decomposition reaction, where a giant compound on action of heat will decompose to components or smaller compounds. That's good. So the next thing now is to balance. And just like what we'll be doing before, nothing is here. So you have lead, which is 1 atom of lead, and you have 1 atom of lead here. And in this bracket, you have NO3, but you have 2 governing everything inside the bracket. Meaning if you have 1 nitrogen atom before, this time around, you're going to have 2 atoms of nitrogen. And if you have 3 atoms of oxygen before now, at this point, you will have 6 atoms of oxygen. Is that okay? That's beautiful. Now, for the product side, you have 1 atom of lead, 1 atom of oxygen, nitrogen 1, O1, and O2 here. So we have a problem. And the problem is, in the case of our oxygen, 2 times 3 here is 6. That is 6 atoms of oxygen. If you come here and add 2 here, to make here 4 plus 1, 5 plus 1, 6. Yes, you've balanced oxygen very well. But you did not take note of nitrogen that as well has 2 atoms. You see, that is where the problem is. And this is where most students find it very difficult to understand. So the best thing to do is to clean the first 2 you wrote and be very, very creative. So if I should add 4 here, yes, balancing is not a guessing work actually, but it's pure chemistry. You have to add values that when you try illustrating them or trying to balance the element will give you equal numbers. You can use 8, you can use 12. But if all the values you invited to balance the equation can be divided by 2, then divide it. What I mean is always try to give it lowest values during balancing. Is that okay? All right. So if you have 4 atoms of nitrogen here, for the reactant side, you have to add 2 here. This 2 is now governing both the lead. I'll highlight this. Both the lead and everything inside the bracket and everything outside the bracket. So it's no more 1 atom of lead. No. You've now produced 2 atoms of lead. How? Because you want to balance the number of atoms of nitrogen. That is the cause of it. And if you don't do it this way, you might not get it right. You understand me right now? All right, let's continue. So if you've reached this point, congratulations. The next thing to do is to balance the lead. So you come here and add 2. Once you add 2 here to lead at the product side, you've done justice to lead, and you've as well done justice to nitrogen. And if you've done justice to the 2 element, it means you as well indirectly done justice to oxygen, even directly. Yes. Because right now you have 2 times 3, which is 6 atoms of oxygen, multiplied by these 2. That will give you 12 atoms of oxygen. Every atom of oxygen for the right hand side, is equal to 12. So you have to make here as well what 12. So you have 2 times 1, that is 2, and 4 times 1, that is 4, plus 2, 6. So we are looking for extra 6 to make oxygen 12. So you come and add 3 here, such that 3 times 2 will give you 6. Understood? Yeah, I believe you understand. You have 2 atoms of lead. You have 2 atoms of lead. You have 4 atoms of nitrogen. So 4 atoms of nitrogen. You have 2 atoms of lead here and 4 atoms of nitrogen here. Then for the oxygen, 2 times 3 is 6 and 6 times 2 is 12. So you have 12 atoms of oxygen. For us to get the same value here, you have to add, and introduce, and that value that will give you 12. So 2 times 1 is 2, 4 times 1 is 4, plus 2, 6. So 6 plus 2 is 8. That is why 8 is not up to 12. So what you have to do is to invite another value. Now when you multiply by this 2, it will give you 6, such that 6 plus 6 will give you what? 12. And if you check, 2 plus this 2 plus this 4 plus 12, that will give you 18. Then 2 plus 4, that is 6. That is 2 plus 4 plus the same 12. That will give you what? 18. Meaning we've what? Done justice to this equation. Understood? All right. If you are here, congratulations. Congratulations. Because balancing will not feel difficult again for you. Is that okay? All right, let's take another example. Assuming you are giving this equation to react and balance, HNO3. I'll be using different compounds so that whenever you see it in your exams, either school exam or WAEC or NECO or GCE or JAMB, you will not find it very difficult. So this time around, I'm using a nitric acid, which is hydrogen trioxonitrate 5 acid. All right. Reacting with CaCO3. This compound is our friend in chemistry, calcium tricarbonate 4. Everyone knows this compound, just the way water and sodium chloride are rampant in chemistry. All right, let's continue. So these are normal trick. Divide it into 2. You have hydrogen as a cation, nitrate ion as a radical. You have calcium cation, carbonate ion as a radical. So this will come here, this will come like this, and this one will come like this. So let's get started. Calcium will react with NO3 to form Ca bracket NO3 2 plus water, because when you have H remaining and carbonate ion, the compound that will be formed will be water and carbon 4 oxide. Understood? All right. So let's continue. Now the next thing is to balance. I will wipe this. People will not get it confusing. Yes, that's good. Let me leave that one. So in balancing, you have to first of all know the element that make up the compounds in this equation. That is the first thing to know. So we have hydrogen, we have nitrogen, we have oxygen, and we have calcium, and finally carbon. So these four compounds produced, um, they have four principal or five. Okay, one, two, three, four, five principal elements that make up these compounds. So the first compound, which is HNO3, has one atom of hydrogen. And here we have, sorry about that. Here we have two atoms of hydrogen. Is that okay? So that is not balanced. You have to balance it very well. And to balance that, you have to add 2 here. Trust me, if you add 2 here, you produce new compound which is not existing in chemistry. So be very much careful during your balancing. Any wrong move will result to wrong balancing, and that is wrong answer in the end. So you have 2 atoms of hydrogen here, and you have 2 atoms of hydrogen here. You've taken care of hydrogen. The next thing is to take care of nitrogen. And I want to say this: it's not a must you will balance all these elements one after the another. You can start with any one of your choice. As far as that particular one will help you to reach your goal very faster. So that is what you should note this period. So you have 2 nitrogen, then here 2 times 1, that is 2 nitrogen. For oxygen, you have 2 times 3, which is 6, plus 3, which is 9. So you have 9 oxygen atoms. And here you have 2 times 3, that is 6. 6 plus 1 is 7, and 7 plus 2 is 9 oxygen. Remaining 2 atoms, or 2 elements, as the case may be, calcium and carbon. So you have 1 atom of calcium, and 1 atom of calcium, 1 atom of carbon, and 1 atom of carbon. So in this place, you've actually balanced the whole equation. Remember what reacted and what was formed. Hydrogen trioxonitrate 5 acid reacted with calcium triisocarbonate 4. This is an acid. This is also known as limestone or chalk, as the case may be, to form calcium triosonitrate 5 is a salt. Yes, this is nitrate salt. Then water and carbon dioxide. Understood? So in the balancing, you add 2 here, and this will do justice to the remaining part of the equation. If you are here with me and you've gotten to this point, congratulations, because you will soon start controlling chemistry. You will soon understand that chemistry is not as hard as people do perceive it to be. It's all about principles and understanding the principles. A step missed is a very detrimental one. So let's do one more example. Assuming you're given this compound, let's take phosphoric acid. So if you're given H3PO4 reacting with, let me use a very simple one that we know, Na, okay, with N, okay, sorry, let me use another element that will be a bit difficult, that is Ca, to form Ca2, Ca3 bracket PO42 plus hydrogen gas. So this is another equation that sometimes feel so difficult for students to take care of. So in this tutorial, we will deal with this personally. Are you with me? That's good. So this is H3PO4 hydrogen tetraoxophosphate 5 acid. Is a phosphoric acid. Yes. Reacting with calcium to form calcium tetraoxophosphate 5. So the reason why I have these three here is because our PO4 is like this, PO4 3 minus. And you have calcium to be 2 plus. So this 2 is coming from calcium and this 3 is coming from PO4. This 2 is coming from calcium and 3 from PO4. Understood? Nothing difficult here at all at all. It's all about listening very well and following what I'm doing. So let's balance. This is a bit complex. Yes. So you have to listen very attentively. You have H3 here, but here you have H2. So that is not, good for us. You have Ca3 here, but here you have 1. So I will start with this. I will add 3 here to make calcium 3 and calcium here 3. That's great. And the next thing to do is to balance the hydrogen. So if I should add 2 here, that will make my hydrogen total of what? 6 atoms, because 2 times 3 will give you 6 atoms. Then I will come here and add 3. 3 times 2 will give you 6. So I've balanced, just balanced hydrogen. So the next one here is PO4. And in this bracket here, we have 2 PO4, meaning we have 2 phosphorus and 2 times 4 oxygen will give you 8 oxygen. So same thing here, because this particular 2 is governing everything in this compound. So 2 times 1P will give you 2P and 2 times 4 will give you 8 oxygen. So let me write them out. 6 atoms of hydrogen, 2 atoms of phosphorus, 8 atoms of oxygen, 3 atoms of calcium, 3 atoms of calcium, 2 atoms of phosphorus, 8 atoms of oxygen, and 6 atoms of what? Hydrogen. Let's add them together. 6 plus 2 plus 8 plus 3. And 6 plus 2 is 8. 8 plus 8 is 16. And 16 plus 3 is what? 19. Very beautiful. Now 3 plus 2 plus 8 plus 6. So 3 plus 2 is 3 plus 2 here is 5. And 5 plus 8 is 13. 13 plus 6 is 19, meaning we are correct. So tell me, where is the difficulty in equation and balancing of it? There is no difficulty. Like I said before now, understanding the element that make up the compound in that chemical equation will be the first step to note. Second thing is understanding the atoms of the element in the compound. You understand me right now? Once you have that, you react. Let the cations attract the anions or the radicals. In that case, take care of their valencies. You understand me right now? So after that, you balance them atom by atom. You can use any value that you feel good in balancing, but always reduce that value to its lowest one if all the values in that particular side can be divided by 2 or 4 or 3, as the case may be. Once you've gotten that, you take care of the values in and outside the bracket. The value outside the bracket will always govern all the values inside the bracket. So if you have 2 oxygen before inside the bracket, you will have 4 oxygen after the bracket, and that is the actual value you should work with. Understood? And another thing that is very, very much good as a chemistry student to understand is the state of this compound or element. For example, calcium is solid, H3PO4 is aqueous, CaPO4 is aqueous, and hydrogen gas is gas. So that is gaseous. I am not adding that here because it's going to confuse many of you. Like it will confuse many of you. So let's take it this way for now, a step at a time. So let me go back to what we did before now. Nothing is here, so don't get intimidated. What we treated today in today's tutorial is balancing of chemical equations, and I've given you the best trick that you will use to balance chemical equations. So in our next video, we will look at naming of chemical compounds before we step into higher topics in chemistry. So if you are with me to this point, please subscribe, like, comment, and share so that you will not miss my next videos. And do not forget that this is our great academy where chemistry is made easy. See you in the next tutorial.